this on. There we go. So, rational function is one polynomial divided by another polynomial. And the first characteristic that we look at are non-permissible values. Because non-permissible values either result in vertical asymptotes or holes. And just a note off to the side, another name for a hole, in case it comes up on a final exam. I think on one exam, a couple of years ago, they just said, what is the point of discontinuity? And some classes had only learned about holes, so people were confused. Some people figured it out. The next exam said, what is the point of discontinuity? And then in brackets it put hole. So hopefully they say both on the exam. Okay, so for this first example, we have two non-permissible values. X can't equal 3 and x can't equal negative 1. Would those be vertical asymptotes or holes? They're going to be asymptotes. Since nothing cancels out, they'll both be asymptotes. But if we look at this next example, we have non-permissible values only at x equals 3. And in this case, the x minus 3's cancel out. So we get a hole. That equation has a hole when the x value is 3. Now, as far as graphing this one goes, once you simplify the x minus 3's, your equation just becomes x plus 1. And that is a straight line with a slope of 1 and a y-intercept of 1. So you can draw that straight line, except you need to draw that line with a hole in it. How do we find the coordinates of the hole? Well, to find the coordinates of the hole, you'd say, well, that hole is also on that line. So if the hole is on the line, when x is 3, what would y be? 4. All you have to do is plug in 3 for x to find out what the y coordinate of the hole would be. Okay, so let's go to example 1. Part A. So the first thing we're always going to do is we're going to factor things completely. So this has a difference of squares on the top. That difference of squares gives us x plus 5 times x minus 5. So we have a non-permissible value. X can't equal negative 5. Question is that going to be a hole or a vertical asymptote? This is going to be a hole, because these ones here cancel out. And our equation becomes just y equals x minus 5. So if our equation is just y equals x minus 5, we can even say where the hole is at. The hole is at negative 5, comma, what will the y coordinate be of our hole? Negative 10. Again, we can figure that out by plugging in a negative 5 for our x. Now, if we were going to graph this, the first thing we find is whether or not we have vertical asymptotes or holes. The second thing we're going to look at is whether there's any other asymptotes. But once this simplifies to just y equals x minus 5, you know how to graph y equals x minus 5. That's just a straight line with a y-intercept at negative 5 and a slope of 1. So over 1, up 1, over 1, up 1. It looks like this. And it's going to have a hole at negative 5, negative 10. For our second graph, for part B, If we factor it, we could factor out a 2 out of the top, leaving us with 2 times 2x plus 1. And on the bottom, we still have x minus 2. So our non-permissible value, x can't equal 2, is going to be a whole or a vertical asymptote. This time, it's going to be a vertical asymptote at x equals 2, because the x minus 2 doesn't cancel out. Since nothing cancels out, we're also going to look in this one, does this one have a horizontal asymptote? Well, how do we determine if something has a horizontal asymptote or not? We look at the highest powers of x. Can you see that the highest degree is 1? And that in this equation there was 1x on the bottom and 4 x's on the top. So if we take 4x over 1x and simplify that, we get just 4. That means we will have a horizontal asymptote at y equals 4. Now, the question says to use graphing technology to check. Section 2.4 after this, we're going to have to graph these all anyways. So we're going to just start practicing our graphing already because it's going to help us out over the long term. So for this one, once you've found out stuff about your asymptotes, you can start graphing. We know that we have a vertical asymptote at x equals 2. So we can put that in and label it. We know we have a horizontal asymptote at y equals 4. We can put that in. That's going to be our starting point. Next, we're going to look at our x-intercepts and y-intercepts. We'll start with our y-intercept because that's really easy. You just plug in 0 for x. Look at your original equation way up here. If you plug in 0 for x, can you see that you'd have plus 2 over minus 2? That means we are going to have our y-intercept at -1. To find our x-intercept, our x-intercept is when we have 0 for y. And again, a fraction is only equal to 0 when the numerator is equal to 0. Since that's already been factored, what value would make that equal to 0? -1/2. So we have those 2 points. If we just did our intercepts, we would have those 2 points. With those 2 points and our asymptotes, we would know that in this section of the graph, it looks like this. Now, when I talk about sections of a graph, your vertical asymptotes will always separate your graph into 2 sections. So we have done when x is less than 2. We don't know what the graph looks like when x is bigger than 2. And since we didn't get any values from our x-intercepts to figure that out, we need to have at least one more point to draw our graph. So often in these cases, you're going to have to pick another point. I'm going to choose 1 to the right. So when x is 3, what's y? If we go to our equation, let's go all the way to the top to our original equation. Can you see that if you plug in 3 into the top of that fraction, 12 plus 2 will be 14. If you plug in 3 into the bottom of that fraction, 3 minus 2 will be 1. So on our graph, we are also going to have the point 3, 14. Right up here? No, over a little bit. There we go. Does that look about right? Does that look about where 3, 14 might be? Wow. There we go. Let's make it very nice. Oh, yes. Almost looks like French for pie. Okay. 3, 14, way up there. What does this mean? This means that in this part of the graph, it looks like this. So once you've got a point in that section, then you know that it has to approach those asymptotes, and you have your graph. Okay, question number 5 are the first practice ones. We are also going to do example 2 and maybe 3, so we'll do those right away.